Hi, welcome to Parametric House. In this tutorial, I wanted to show you that how you can create these circles inside a boundary and also convert them into a group of point attractors. As you can see here, I can change the number of point attractors I want and their random location. Another thing I can change is their force on the circles, how much they affect it. Flip that if I want to, and then convert these circles into two groups. One is a solid series of circles, and another one is just like a windowed shape of those circles. So you can see that you can switch between that easily, change the number of random points, their location, and how they're going to affect. And flip that. Okay, before we start the tutorial, for those premium users, we have talked about a tutorial of creating random circles inside a rectangle with different locations and converting them into two groups of circles. So that tutorial is also useful if you want to know more about creating random circles inside a rectangular boundary. But this tutorial is going to be focused on a closed boundary and creating these circles inside it. So let's get started. The concept is the same, and I'm going to explain what's going to create the outputs and the results. Okay, first of all, we have a curve as a boundary. I've made this in a front view. So that is maybe, for example, a facade or something. You can give any rectangle you want or any curve you want. For example, if I want to make this a closed curve and just give that to the input and maybe reset the simulation. Okay, so I reset the simulation. You can see that we create the meshes. So as you can see here, this is going to affect the final results. And if I change the location, it's going to update. If I change the shape, it's also going to affect the final results. And we're going to talk about any closed boundary inside it. Remember that always when you want to create a new result, just reset the simulation or simply give this Python script, which I'm going to explain. Okay, let's go and talk about this step by step. First of all, what I want to do is to talk about creating a mesh inside the boundary. So we can use this mesh triangulation and tri-remesh that is going to create a triangular mesh inside the boundary. Changing the length is going to give you more details, and increasing it is going to give you less circles, obviously, because it's going to be bigger. Okay. And that is going to be the first part. It's going to give you a T, which is the remesh, a triangular mesh output here, which we can see here. Another thing here is the dual n-gon mesh, which is really cool. Obviously, if you want to use that to create n-gons, you can use that. And that's the T output, which we really need, the triangular one. The next thing is to use the Kangaroo plugin. And there is going to be, I'm going to use the bouncy solver to get the outputs really fast. The threshold is a small number, and I've also increased the iteration, so it's going to get outputs. You can always use a toggle and give it to the simulation run. So this is a run simulation, and you can put that to true if you want to run it, and false to pause it. And this is going to be the reset simulation. Okay, before we go forward, we need a series of goals. So for the goals, I really like to always use this main show components. And the reason here is that it's going to give you the thing that you want as an output. For example, I want to see the mesh output, triangular mesh. So I give that as the goal. I also like to use the set tree merge to merge my goals together and create different goals. And the good thing is that you can always add different goals if you want to. Okay, so I have two goals inside this example. One is the show, obviously. The second one is going to be the Kangaroo plugin. And we're going to use the goals mesh tangent in circles. So if I just give this as another goal, we go to the D2 or second goal. Because I don't want to define any boundary, this is going to be false, so I can show you what's going to happen. So that is that's all what we need here. We just give that to the output, and as you can see here, something happening here, which is the change of the mesh location. That means that the only force which is affecting the mesh is the tangent in circles. That's it. That's all we are trying to achieve here. And that is going to deform this mesh. Obviously, what it means here is it's going to put a series of circles inside the mesh, and they're going to force each other to go out. So here you can see that. Okay, add that here. There is another goal, which is goals collision sphere collide, which you can give all of the vertices of the mesh as spheres colliding together with radius. But we talked about this in the premium tutorial. But here we want to focus on tangent and circles, which is really easy, and we don't want to get into collisions or anything. So after that, what we have here is an output. Because we have given the mesh show as the output, here we have this as the first output. We just go to the sets and create this list item component and pick it up. So that's all we have to do. Another thing about Kangaroo which is really cool, is that you can use this mesh tool, which I discovered is really easy in tangent and circles. So all you have to do here is to use this tangent and circles as a goals before the simulation. After simulation, you can use this tangent and circles inside it. If I connect this to the main mesh, and reset the simulation, this is the first mesh we have here. You can see that we have a series of circles, inner circles here. And this circle output, as you can see here, they are colliding. So that's the problem. The inner circles is not really that important, because obviously you can create circles inside a triangular mesh, and that's going to be okay. But this one is the most important, which is a circle packing algorithm. But as you can see here, they are colliding. But what if we just use this tangent and circles goal and then give that to the output? So I'm going to put this next step to false. And here you can see it's going to help you to create that results. Let's run the simulation. And as you can see here, it's fixing it. That's it. That's all you have to do with a simple tangent and circle goals. Okay. Before we go forward, another thing you can do here is to define a boundary. Just talk about that too. For the boundary, what I've used here is a curve offset to offset the curve outwards, for example. Okay. And I've also used a dash pattern to show you what's just like a dash pattern on it. And let's say, okay, offset the boundary. This is a good thing if you want to go inwards or outwards, maybe -40 to +40, okay, whatever it is. If I increase the boundary, because I have given this as a boundary, you can see that it's stretching out. And if I go inwards, you can see it's scaling it down. But remember, whenever you use that, if you run the simulation, sometimes it's going to have problems. So remember, always, if you want to solve it, it's just easy. Just turn off the boundary offset without any boundary, run the simulation, and then give it a boundary so it expands. And then what you can do here is just scale it to 0. And as you can see, it's jumping here and it will have some problems. Then reset the simulation and you can see it's on the boundary. The most important thing, the reason we're using this is, as you can see, the circles are getting out of the boundary, but what we can do is to bring them inside. So if I put that, it's going to snap back without any offsets to the boundary. Or you can just scale it outwards if you want to, scale it inwards, or just put this to 0 and run the simulation and get the good results. So that is also the only thing I wanted to add about the boundary. I'm going to put this to false. And you can just test that for yourself. Anyway, after creating the circles, what we can do here is to put them into two groups, and I've turned this into a button and use this set sequence call pattern to say, okay, do you want to continue or not? So the next step is false, and I've turned this on by inverting this. I mean, I want this as an output, so you can have the circles here, obviously. Let's select them here and see that. Okay. You can see that we can have them as an output here. But what we want to do here is to say, no, I want to go to the next step. So obviously you can turn this on. Let's just turn off the last step here. So this next step is going to run here, and we will have two groups. And I'm going to explain this here by turning on this green and red so you can understand it here. Okay. And the reason I've done this is to put them into two groups of point attractors. Now I have used the boundary, brought it here, connected to a surface to create a surface from it. Obviously, it's going to be a surface like this. And I want to create those random points inside it. So I've used this vector grid populate geometry to create two random points inside it. As you can see here, they are these 2 points. And then the seed is going to change their location. So if I put it to 0, everything is going to be selected. If I put it to 1, we'll have 1 point attractor with changing locations. If you want more, just increase that. And create new locations with number and seed. After creating that, what we have done here is, let's create it with a line. These attractors are selecting the circles for themselves. So what you have to do here is to use the vector point and pull point to pull towards pull the center of all of those circles, an area, simple area that we have extracted from the circles, towards the point attractors. That's going to, if I connect it with a line, you can see that easily. That's going to give you the distance. Because the distance is different for each of the circles, they are big, small, 5. As you can see here, we have a small number of 5 here. We have 75 here. So those numbers are not really controllable or easy to control. So what we can do here is to go to the math and remap the numbers. That means scaling the numbers, whatever it is, to a target of 0 to 1. Okay, so what you have to do is to say, okay, I want to scale the numbers. What is the domain? You just use this simple bounds component. You give it to it. It's going to be, okay, it's between, I don't know, between 5 and 80. So what you have to do is to give the values, define the bounds of the numbers, and now you just give the target domain. By default, it's 0 to 1, which is perfect because we need them to be scaled into 0 to 1. After creating that, we can say, okay, is it smaller than a number? So we just go to the math, smaller than, and we define a goal, smaller than a number. And then we can have a series of true falses. And that's what we will have for dispatching. You can use dispatch here, but what I have added here is an additional component. And that means, okay, it's going to give you a series of true falses. What if I make it false and true? Okay, so this is going to give you a series of, for example, it's going to be true, true, false. And the second group is going to be false, false, true. And the reason here is just to make a switch between the groups of circles, solid circles, and the boundary or the border ones, right? So I just found this technique really simple. You give it a Boolean, you invert it, and you just flip that. Okay, that is going to be a set list v, and selecting between 0 and 1. And then you just dispatch all of the circles based on this logic. I've created this coloring thing here. As you can see here, we can switch between them and define their affection, how they're going to affect it, the location, and that's it. Okay, now that we have them into two groups, we are good to go. And what we have to do here is to go for some simple extrusions or bordering. So for example, the group list true is going up here. Again, I made a switch to say, do you want to go to this next group, next step? And you said true. Okay. So it's going to give you, I think that we can go to the rendered mode to see it even better. And again, I made do all of it to make it for visualization. You can see that you can switch between the coloring or you want to go for the solids. Okay, when you go for the solids, you just get the curves, you convert that into a surface. For example, the solids. That's going to create surface from the circles. And then we extrude them. That's it. Surface, freeform, extrude. The direction is going to be a vector. The vector I've used here is I've connected the vector to the curve. So I think that if you rotate it, it's going to automatically select a normal. That's it. So you just connect the vector to it. It's going to be the normal direction. And you give it a multiplication and you extrude it. I've just made another vector because I've used it in the bottom parts. So that's going to be the extrusion. And you will have these parts here. And that's it. The extrusions. And another thing that we can do here is to give it a color and rewrap edges to see the edges. Okay, not really that important. The next part is the circles with borders. So what I want to do here is to bring the curves, create an offset. This is the curve. This is the offset. I've intentionally graphed that. If you don't know about these things, you can watch the data management sections in Paracourse. We have talked about it. We have also some free tutorials. I'm going to put it up here if you want to check it out. We've talked about data management, about graph and simplify those things before. But anyway, now that we have this offset, we can say, okay, we want to create a surface from that. Instead of loft, I've used the surface freeform ruled surface, which is going to give you a really clean surface for that. Select it, bring it out. You can see that. And then we can just simply extrude it, right? Extrude it in the same direction of this vector. Some rewrap edge preview. Again, for the offset, I've moved that back and made a surface to create the windows and a blue color. That is going to be the whole part. If I remember that this has to be in a plane. So I can go set C plane to the object. And let's go and set the C plane back to top, which means the perspective view. And here you can see that it's going to run. Okay. You can turn anything. Okay. For the automatic reset, you can use this Python script, which uses, adds a number. For example, the area of the mesh here. If I give that the reset. For example, let's scale it. It's going to run the simulation multiple times. And this is good if you don't want to each time click this reset button. Okay. I'm going to put this as an additional one. You just get, for example, the area of the mesh is going to update. Maybe you want to add also this one. So just use the shift key and add it to the goals. And it's going to get those numbers, mass add them up. So it's going to create new numbers each time, and use this Python script from Anders DeLorean to get that new output, reset output each time. So as you can see here, it's false, but whenever I change that, it's going to jump to true and then go back to false. So this is also a good switch you can use. I'm going to put it up here, internalize this so you can use it. Reset the simulation. If you want to, you can also add that one. And that's it. That's all for this example file. I hope that this tutorial was useful. Again, if you want to know more about this, you can watch this tutorial. We have talked about creating random circles inside a rectangle, which has some cool techniques. But anyway, I hope that this tutorial was useful. If you have any question, ask below this lesson. See you next time. Bye. Remember that you can download these example files all from our website, parametrichouse.com. And remember to subscribe to our channel, like this video, share it with your friends, and let me know in the comments if any additional examples you need so we can record the tutorial. Thanks for watching. See you next time. Bye.